Welcome to this lesson on ketones, one of the most important functional groups in organic chemistry. Ketones are organic compounds that contain an internal carbonyl group, which means a carbon-oxygen double bond located within the carbon chain. The general structure of a ketone shows the carbonyl carbon bonded to two other carbon atoms, represented as R-C equals O-R', where R and R' represent alkyl or aryl groups. Let's define what ketones actually are. Ketones are organic compounds containing a carbonyl group, written as C equals O, that is bonded to two carbon atoms. This is what makes them unique. The carbonyl group is the functional group responsible for the chemical properties of ketones. Unlike aldehydes where the carbonyl is at the end of the chain, in ketones the carbonyl carbon is always bonded to two other carbon atoms, making it an internal carbonyl group. Now let's examine the key structural features of ketones. First, the carbonyl position is located within the carbon chain, not at the terminal end. Second, the bonding pattern shows the C equals O group bonded to two alkyl or aryl groups. Third, the carbonyl group itself is the reactive center of the molecule, where most chemical reactions occur. Finally, the carbonyl carbon atom has sp2 hybridization, which gives it a trigonal planar geometry with bond angles of approximately 120 degrees. Let's look at some common examples of ketones you'll encounter. Acetone, also known as propanone, has the formula CH3-C equals O-CH3. It's the simplest ketone. Butanone, with formula CH3-C equals O-CH2CH3, is also called methyl ethyl ketone. Cyclohexanone is a cyclic ketone with molecular formula C6H10O, and acetophenone, with formula C6H5-C equals O-CH3, is also known as phenyl-methyl ketone. These are widely used in industry and laboratories. Naming ketones follows specific IUPAC rules. Step 1. Find the longest carbon chain that contains the C equals O group. Step 2. Replace the -E ending of the corresponding alkane name with -1. Step 3. Number the carbon chain to give the carbonyl carbon the lowest possible number. Step 4. Indicate the position of the carbonyl group and name any substituents alphabetically. Following these rules ensures you can correctly name any ketone you encounter. Ketones have distinct physical properties. They are polar molecules because of the dipole moment created by the C equals O bond. However, ketone molecules cannot form hydrogen bonds with each other because they lack hydrogen atoms bonded directly to oxygen. This affects their boiling points, which are higher than alkanes of similar molecular weight but lower than alcohols. Small ketones like acetone are soluble in water because they can accept hydrogen bonds from water molecules through the oxygen atom of the carbonyl group. Ketones undergo several important chemical reactions. Nucleophilic addition reactions occur when the carbonyl carbon is attacked by nucleophiles, forming alcohols. Reduction reactions convert ketones to secondary alcohols using reducing agents like sodium borohydride or lithium aluminum hydride. Unlike aldehydes, ketones resist oxidation, which makes them more stable. Ketones also participate in aldol condensation reactions, which are base-catalyzed reactions that form new carbon-carbon bonds, making them valuable in organic synthesis. Ketones have numerous practical applications. As solvents, acetone is widely used in nail polish removers and industrial cleaning processes. In chemical synthesis, ketones serve as important intermediates in the production of pharmaceuticals and polymers. They're used in fragrances, appearing in perfumes and flavoring compounds. In the pharmaceutical industry, ketones are crucial building blocks for drug synthesis and play important roles in medicinal chemistry. Their versatility and reactivity make them indispensable in both laboratory and industrial settings.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.